Welcome. In this lesson, we're going to dive a little bit deeper into polymorphism and talk about how it works behind the scenes. Fair warning, this is probably not one that you want to half pay attention to or speed through because it can get a little bit complex to understand, so taking your time would be advisable. We only have one learning goal for this lesson, and that's that you can explain how Java evaluates polymorphic expressions. The examples we use today are going to be based on the hierarchy on the right. Notice we have a superclass employee. Employees have a job title and a pay rate. And we also have two subclasses, hourly employee and salaried employee. Now, there's some details we don't care about so much for right now, but one thing you really want to pay attention to is that the employee superclass has a method called getPaycheck, and it returns the employee's paycheck as a string. An hourly employee and salaried employee override this method. Suppose we want to keep track of a restaurant staff. To do this, we might create an array list using polymorphic references. Remember that the idea behind a polymorphic reference is that the reference type and the actual object type can be different. So in this case, we create an array list of employees. And that means that we can put anything in the array list that is an employee. So you'll notice the first three objects I add are new hourly employees, and the last two are new salaried employees. So the array list holds 5 objects. Each object is an employee, but they're all specialized or more specific types of employee. And in the end, with polymorphic references, this can save us code because we don't have to make multiple array lists or possibly use multiple loops to process them. Now that we have an array list of employees, we'd like to pay them all. And so what we do is we have a loop where we say for each employee E in the list, println e.getPaycheck. And the getPaycheck method will return a string containing the name and how much the employee gets paid. And you can see the output of that on the right. The question is, how does this work? When we say e.getPaycheck, how does Java know which getPaycheck method to call? After all, there's one in the superclass employee, but there's also ones in the subclass that are overridden. And so what does Java do with all that, and how do we make sure we get the right output? This is what we're going to unpack on the next slides. Polymorphism can get really confusing really fast because there's so many different class names flying around. So before we dive in any deeper, we need to get on the same page. We know that when we do polymorphic references that we have a reference type and we have an object type, right? The type on the left when we create the reference isn't the same as the type on the right. And so in this case, our references are all employees. I'm going to make an array list full of employee objects, but not actually, right? Because what's in the array list is going to be the more specific type of employee. Here we see the hourly employees and the salaried employees. So we're going to make a distinction between those classes. So we're going to call employee the declared class or the reference class. So the array list is really going to be full of references to employees, but the actual objects inside are not employees, they're more specific. The actual objects are hourly employee and salaried employee, and we'll call these the instantiated classes or the classes of the actual objects we create. On the right-hand side of your screen, you can see a graphical representation of our array list. Remember, the declared type of the array list is employee, and so these blue arrows represent employee references. However, the actual objects they point to are 3 hourly employees and 2 salaried employees. I color-coded them for clarity. Now, what we want to do is loop through this array list and generate the paychecks for all the employees. And so you can see that we have the for each loop. For each employee E in the list, we're going to call paycheck or get paycheck on the employee. Now, how does Java handle all this? It actually starts before we even run the code. And what happens is that before we run the code, Java's already checking. It sees that we have a method call here, getPaycheck, And so what it does is it checks the declared class to make sure that method exists. Now remember, the declared class is employee, right, for each employee. So we look in the employee class and we verify that the getPaycheck method exists. If it doesn't, Java's not even going to let us run the code. Once the program is running, Java will now take a look at the actual objects. So the first pass of the loop for each employee E is going to refer to the very first employee in our array list. And at this point, Java, before we ran it, it already checked to make sure the getPaycheck method existed in the declared class. So now it's going to check the instantiated class. Java is going to look at that object, realize it's an hourly employee, and it's going to check that class for the method and call it. And so when we process our first employee, it's going to call the getPaycheck method in the hourly employee class. On the second pass of the loop, E now refers to the second employee. Again, Java is going to take a look at that object and realize that that is an hourly employee object, so it is going to call the hourly employee's version of getPaycheck. On the third pass of our loop, E refers to the third employee, and again, Java will realize that this is an hourly employee and call that version of the method. On the fourth pass of the loop, things change a little bit because Java looks at this object and realizes it's a salaried employee object, so it goes to the salaried employee class and calls its version of the getPaycheck method. I'm sure you figured it out by now, but on the last pass of the loop, E refers to the last object, which again is a salaried employee, so that version of the method gets called. In the previous example, each of the three classes had their own versions of the getPaycheck method. We saw it in the employee superclass, which was the declared class, but then hourly employee and salaried employee overrode it with their own versions. So what would happen if we actually removed the getPaycheck method from the employee class? Now, hourly employee and salaried employee still have it, but how is Java going to respond to this? If you think back to the beginning of this example, we talked about the fact that Java actually does some things before we even run the code. And specifically, when Java sees that method called getPaycheck, it's going to check the declared class to make sure it exists. Now, the declared class for the array list is employee. And when we look in the employee class, we can see that the getPaycheck method has been removed. So Java is going to throw an error and it won't even let us run our code. So this is something we really cannot remove if we want to use polymorphism in this way. So we know we need to have the getPaycheck method in the employee class, but what if we were to choose not to override it in one of the subclasses? So in this case, I'll remove it from salaried employee. So how is Java going to handle this situation? Since we do have that getPaycheck method in the employee class, the code is going to run this time. Java is not going to have a problem with it. And so let's say we're working through the loop and our employee E refers to one of the salaried employees. Now, we know that while we're running, Java is going to realize it's a salaried employee, and it's going to call the getPaycheck method in that class if it exists. But since it doesn't exist, we're still okay, because if we don't override the method, then Java can simply default and run the method that is inherited. So it works, right? If the method's overridden, it will call it. Otherwise, it will just call the one that it inherited. And by the way, this is why we have to have getPaycheck declared in the employee class, so that if we call a method on the actual object and it doesn't exist there, there's still one that is inherited that can be called and it doesn't throw an error. We've seen lots of examples today, so I'd like to finish by just summing up what we've talked about, because it all has to do with what happens when we call a method. So the first thing is, before we run the code, Java is going to make sure that that method exists in the declared class. But then while the code is running, Java is going to look at the actual object, and it's either going to run the method in that object, or it will default and run the inherited method from the declared class. To check your understanding, let's consider a non-polymorphic reference and object. So in this case, I'll use the string class. So we've got a string reference equals a string object. It's non-polymorphic because the two classes are the same. And then we call a method s.substring. So the generalizations we talked about on the last slide, do they still apply here? So I put the generalizations down below just for your reference, but something happens before running and something happens while running. And the question is, are these special rules that only apply to polymorphism, or could we say that Java does the same thing here with this non-polymorphic method call? Pause the video, and when you're ready, we'll talk about the answer. The short answer is yes, these generalizations still apply. However, because we're only working with one class, some of the circumstances can never happen. So let's just walk through them. So before running, Java makes sure the method exists in the declared class. So the declared class is string. Java makes sure that the substring method does exist in the string class. Okay, so that's check, and we're able to run the program. Then while running, Java looks at the instantiated class, the class of the object, which is also string, and either runs the method in that class or it runs the inherited method. Now, inheritance doesn't apply here, so bullet point 2 is off the table. But it will run the method in that class, and oh, by the way, we already know that that method exists because Java already checked it before running. So it's the same thing, but when there's only one class in play, it's just a lot simpler. Now that you've watched this lesson, you should be able to explain how Java evaluates polymorphic expressions.